In this video, we will go over some limiting and excess reactant practice problems. So a very quick review on what is the meaning of limiting reactant. It is the reactant that used up first, and it limits how much product will form. So in this example, the meat patties limit the number of burger because they run out first. So no more hamburgers could be made without more meat patties. So that is the limiting reactant. In this particular diagram, we can see that the green dot is the limiting reactant because after the reaction, there are red spheres left unreacted. So they are the excess reactant and the green is the limiting reactant. Now let us see how to find out the limiting and excess reagent when a balanced chemical equation is given. And in this equation, CH4 plus 2O2 gives CO2 plus 2H2O. If the reaction involves 5 moles of methane and 8 moles of oxygen, find the limiting and excess reagent. So what we have to do here is first we will find how many moles of one of the product is forming from each given number of moles. And then we will see which one is giving us the less number of moles of product, that is going to be our limiting reagent, and the other one is going to be our excess reagent. So first I will find the 5 moles of methane and then I will find for 8 moles of oxygen. One of the product I can take and I'm going to take carbon dioxide as the product. It's not necessary that we have to go with carbon dioxide, but I'm going to take carbon dioxide now. So first one, 5 moles of methane, and the conversion factor between methane and carbon dioxide is for 1 mole of methane from the balanced chemical equation that corresponds to 1 mole of carbon dioxide. So that's the conversion factor. So moles of methane and moles of methane cancels. And how many moles of carbon dioxide I will have? 5, because that's a number in the numerator here. 5 times 1 mole of carbon dioxide is 5 moles of carbon dioxide divided by 1. So it is not going to make any difference. So in the second case, with 8 moles of oxygen, so 8 moles of oxygen I will start with. You can write divided by 1. It does not make any difference if I am not writing as well. So then from the balanced chemical equation, 2 moles of oxygen corresponds to 1 mole of carbon dioxide. So that equal moles of carbon oxygen and moles of oxygen cancels. So 8 times 1 mole of carbon dioxide is 8 moles of carbon dioxide, and in the denominator I have 2. So that equal 4 moles of carbon dioxide. So I can see that the carbon dioxide produced from 8 moles of oxygen is less than carbon dioxide produced from 5 moles of methane or CH4. So less number of moles produced from 8 moles of oxygen. Therefore, oxygen is the limiting reagent in this case. And definitely which is going to be our excess reagent? CH4 is the excess reagent. All right. And now the other method, the cross multiplication method of the same problem. So the equation is CH4 plus 2O2 gives CO2 plus 2H2O, and we have 5 moles of methane and 8 moles of oxygen. I will write that one. And first I will do for methane, and from the question I have 5 moles and how much carbon dioxide it will form, that's what I'm going to calculate. And from the equation, balanced equation, I have 1 mole of methane and 1 mole of carbon dioxide. So when you cross multiply, we can find how many moles of carbon dioxide it will form. So 5 times 1 divided by 1. So I will get 5 moles of carbon dioxide. And for oxygen also I will do the same. So for limiting reagent, if there are 2 reactants given, we have to do for both, right? So 8 moles of oxygen gives how many moles of carbon dioxide. And from the equation, valence equation says that 2 moles of oxygen corresponds to 1 mole of carbon dioxide. So we can cross multiply. That means 8 times 1 divided by 2, that equal 4 moles of carbon dioxide. So we can say that 4 moles of carbon dioxide is less number of product. So that is going to be our limiting reagent, and methane is going to be our excess reagent. Here is another question. So that is 39 grams of zinc are reacted with 42.6 grams of hydrochloric acid. How many grams of zinc CnCl2 will be produced? Which reactant give the smallest amount of reactant? That means we have to find the limiting reagent, and they specifically said which product we have to consider, that is ZnCl2. So I will first find with the Zn, and then I will find with the hydrochloric acid, and then I will see which one gives the lowest number of moles. Or since they said the grams, I will go with the grams. Okay, I will find the mass instead of moles. Okay, so let's go ahead and start with the first one, which is Zn. Okay, so that means 39.5 grams of Zn times the conversion factor. I have to convert that one into moles. So 1 mole of Zn, since the grams given, I have to always convert that one into moles to compare with our equation. So if you look in the periodic table, you can see the molar mass of zinc is 65.39 grams of Zn. And then I will connect that one with the equation. That means 1 mole of zinc, stoichiometric relation between zinc and ZnCl2 is 1 mole of ZnCl2. So I will not stop at moles because they said grams. So I will convert that one into grams. That means in 1 mole of ZnCl2, if you calculate the molar mass, if you look in the periodic table, Zn is 65.39, chlorine is 35.45. There are 2 chlorine, so 35.45 2 times. That equals 136.29. So that will go in the numerator, 136.29 grams of ZnCl2. And that's all I need because I will get it in grams. So moles of CnCl2, moles of CnCl2, moles of Cn, moles of Cn, grams of Cn will cancel, and I will have grams of CnCl2 in the numerator, and other numbers are 39.5 times 136.29 divided by, I have 65.39, and the unit here is grams of ZnCl2. So I will have 82.8 grams of ZnCl2. And now let's go ahead and see for HCl. So for HCl, we have 42.6 grams. So second one for HCl, 42.6 grams of HCl. The convert it into moles. So that means when you take the molar mass from the periodic table, we will get 36.5 for HCl in 1 mole. Okay, and I have to see the relationship in the stoichiometric relationship in the balanced chemical equation. So 2 moles of HCl corresponds to 1 mole of CnCl2 from the balanced chemical equation. Now I had to convert that moles to mass. 1 mole of ZnCl2 equals 136.29 grams of ZnCl2. Okay, and now we can cancel grams of HCl, moles of HCl, moles of HCl, moles of CnCl2, moles of CnCl2. So which are the numbers in the numerator? 42.6 times 136.29, and the unit is grams of ZnCl2 divided by the numbers in the denominator, 36.5 times 2, that will give us 79.6 grams of ZnCl2. So we have less number of grams of the product here. So HCl is the limiting reagent. Okay. So which reactant gives the smallest amount of CnCl2? That's a question. So HCl gives the lowest number or smallest number of the product. So that's the limiting reagent, and zinc is our excess reagent. The same question with the cross multiplication method. So I have Zn information given. So Cn is 39.5 grams. Convert that one into moles, 65.39 from the periodic table for the Cn molar mass. So then I will get that one as 0.604 moles of Cn. So how many moles of CnCl2 is that? So according to the equation, I have 1 mole of ZnCl2 because coefficient is 1, coefficient is 1. So 1 mole of ZnCl2, and then cross multiply. I will get 0.604 moles of CnCl2. Convert that one into molar, multiply with the molar mass. Convert that one into grams. To convert that one into grams, so that will equal 82.3 grams of ZnCl2. And then I have information for HCl. So HCl is 42 points. So under HCl I will write 42.6 grams divided by 1 plus 35.45. To convert it into moles, I will get 1 point that equals 1.169 moles of HCl. So now according to the equation, I have for 1.169 moles divided by 2 moles of HCl in the equation and 1 mole of ZnCl2. So 1.169 will give how many moles of ZnCl2, and according to the equation I have 1, so then cross multiply. So that equal 1.169 divided by 2, that equal 0.589, and then multiply that one with the molar mass, and I will get 79.59 grams of ZnCl2. So I have less number of grams here, so that is going to be my limiting reagent.